Hello students, welcome back to physics class. This is motion chapter part 8. Make sure that you have watched all the videos till part 7 before going ahead with this part 8. Okay, is it clear children? So now we can start the class, right? So first, a recap from last class means topics to be discussed in last class. So first we have discussed graphical representation of motion. In that we have discussed distance time graph for uniform and non-uniform motion, velocity time graph for uniform and non-uniform motion, non-uniform acceleration, and we have done problems on graphical representation of motion. Okay, so in distance time graph, uniform motion shows a straight line because equal change in distance in equal interval of time. So non-uniform motion, it shows a curved line. The same way, even velocity time graph also for uniform acceleration, it shows straight line because it varies equal velocity in equal interval of time. So for non-uniform acceleration, it's a curved line. Next, we have discussed problems on graphical representation of motion. Okay, so we found acceleration and a type of acceleration, and by using graph we found by using velocity time graph we found acceleration of an object. Okay, next, so topics to be covered. So today we are going to cover these two topics. First one is equations of motion, second one is problems on acceleration as well as equation of motion. Okay, so by using equation of motion and acceleration formula we can do problems here. These are three equations of motion. So these equations we have derived by using graphical representation of motion. Okay, so there are three equations of motion. First one is V is equal to U plus AT. You know what is meant by V, U, A and T. V means final velocity, U means initial velocity, A means acceleration. Okay, so this is first equation of motion. This equation means first equation of motion describes velocity time relation. Okay, it gives the relation between velocity and time. So which are velocities here? Initial velocity and final velocity and time taken. Okay, it gives the relation between velocity and time. And second one is S is equal to ut plus of at square. Here only 8t is there. T should be square is missing here. Okay, S is equal to ut plus half at square. So this equation of motion represent position time relation, means it gives the relation between position and time. Position is nothing but distance. Okay, S means distance covered by the object or distance traveled. So second equation of motion gives the relation between distance traveled by the object and time taken to cover the distance traveled by the object. Understood? That is second equation of motion. Third equation of motion, 2as is equal to v square minus u square. Here also square is missing. Okay, v square minus u square. So while discussing the sums, so I have given clearly formulas v square minus u square. This is third equation of motion. This equation of motion represents relation between position and velocity. Okay, here there is no time here. Only this equation of motion gives the relation between distance traveled by the object and velocities, initial velocity and final velocity. Is it clear? So, and descriptions of the symbols also I have given here. U means initial velocity, V means final velocity, T means time taken, S means distance traveled, and A is acceleration. So these equations of motions are very important. You have to memorize all these three equations of motion. Is it clear children? So first one, V is equal to u plus at, second equation of motion. S is equal to ut plus half a t square. T square is not there, only t is there. Third equation of motion, 2as is equal to v square minus u square. Is it clear? So now we can start problems on equation of motion and acceleration. So here, before starting the problems, so this conversion also you should remember. You have to know that how to convert kilometer per hour to meter per second and meter per second to kilometer per hour. Listen carefully, okay? So first, kilometer per hour and meter per second, vice versa. First, kilometer. So 1 kilometer is equal to, so 1 kilometer is equal to how many meters? 1000 meter. Per means divided by 1 hour, right? So 1 hour we need to convert into second. Left hand side you see here, kilometer per hour to meter per second. Okay, so 1 kilometer divided by 1 hour. So 1 kilometer we can write 1000 meter, and 1 hour we can convert into second. Is it clear? Now left side, just opposite, meter per second to kilometer per hour. So 1 meter is equal to 1 divided by 1000 kilometer. Okay, 1 second is equal to 1 divided by 60 into 60 hour. Here we are going to convert meter per second to kilometer per hour. Next step. See, 1 kilometer divided by 1 hour is equal to 1000 divided by 3600. First I will explain only left hand side, okay? Kilometer per hour to meter per second. After that we'll go for that. So now if you simplify, 2020 get cancelled. So 10 divided by 30. You listen only left hand side, kilometer per hour to meter per second, okay? So 10 divided by 30. If you simplify, 10 divided by 30, 2 18s are 2 5s are. So 5 divided by 18. So 5 meter divided by 18 second. So 1 kilometer per hour is equal to 5 divided by 18 meter per second. Okay. Now we'll see for meter per second to kilometer per hour. So 1 meter is equal to 1 divided by 1000 kilometer, and 1 second is equal to 1 divided by 60 minutes into 60 second. Okay. So now 1 divided by 1000, if you take reciprocal, so 60 into 60 become 3600, right? We can take numerator and division become multiplication. Okay. So now 1 divided by 1000 into 3600. Anyhow 3600 is in numerator, no? So we can write 3600 divided by 1000. If we cancel two zeros here, two zeros if we cancel, 36 divided by 10. Further if you simplify, 18 divided by 5 kilometer. So this is conversion from meter per second to kilometer per hour. So here kilometer per hour to meter per second is 5 by 18 meter per second, and meter per second to kilometer per hour is 18 by 5 kilometer per hour. We'll see with example now, conversions, okay? Now I'm going to convert 36 kilometer per hour to meter per second. So we'll see now how to convert. So 36 kilometer per hour is equal to 36 into 5 by 18. So you have to multiply it by 5 by 18. If you multiply it by 5 by 18, so that is a conversion of meter per second, kilometer per hour to meter per second. So if you simplify further, 18 ones are, 18 twos are, so 2 into 5, so that is 10 meter per second. So 36 kilometer per hour is equal to 10 meter per second. You see this side, meter per second to kilometer per hour. 10 meter per second I'm going to convert into kilometer per hour. So here we got 36 kilometer per hour is equal to 10 meter per second. Now ulta we are doing, means just opposite, 10 meter per second to kilometer per hour. So 10 meter per second to kilometer per hour, what we have to multiply? We should multiply it by 18 by 5. Just opposite, you have to interchange numerator and denominator, okay? So now if you simplify, 5 ones are, 5 twos are, 2 into 18. So what answer we got? So 36 kilometer per hour. So you understood? Hmm? If you want to convert kilometer per hour to meter per second, you should multiply it by 5 by 18, and meter per second to kilometer per hour, you should multiply it by 18 by 5. So finally, this you have to remember, okay? So kilometer per, oh, here per hour is missing, so I didn't write here. So that is kilometer per hour to meter per second. Only I have written meter per second. So we have to multiply it by 5 by 18, and meter per second to kilometer per hour, we have to multiply it by 18 by 5, just opposite. This last two you remember, okay? So next we'll start doing the sums. So this is the first one, problems on acceleration and equation of motion. This is the first sum. Listen carefully. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find acceleration of the bus. So we have to find out acceleration of the bus. Here bus is decreasing the speed. Decreasing the speed means it is a deceleration or negative acceleration. So you have to get negative acceleration. Okay. So minus value you have to get. Keep in your mind. Bus is decreasing speed, right? So now we'll write given. So what they have given? Initial velocity they have given. And one thing you should remember here, speed they have given here kilometer per hour, but time is in second. So first we have to convert this kilometer per hour to meter per second. So in previous slide we know that how to convert kilometer per hour to meter per second. Okay, so you understood why we have to convert? Because here time is in second. So time is in second, and velocity is in kilometer per hour. So we can't calculate as it is. So we have to convert. All the units should be in a one format. That should be SI format or SI unit. Is it right? So first we have to convert these velocity kilometer per hour to meter per second. Okay. Initial velocity u, because a bus is decreasing speed from 80 km per hour. So here 80 km per hour is the initial velocity. So this one I am going to convert into meter per second. If you convert 80 into, we should multiply it by 5 by 18, right? So 80 into 5 divided by 18. So 80 into 5 is 400. So 400 divided by 18. Further, if you simplify the two table, you will get 200 divided by 9. If you convert into a decimal, 22.22 meter per second. Okay. So this is 80 kilometer per hour is 22.22 meter per second. If you go for final velocity, same way, 60 kilometer per hour. So kilometer per hour we have to convert into meter per second. So multiplied by 5 by 18. So 60 into 5 is 300. So 300 divided by 18. Further, if you simplify, 50 divided by 3. So 50 divided by 3 is 16.66 meter per second. So this is conversion from kilometer per hour to meter per second. And time they have given 5 seconds. So we know the formula to calculate acceleration. A is equal to V minus U by T. Substitute all the values here. A is equal to, and what about V here? Final velocity is 16.66 minus 22.22. 22.22 is initial velocity divided by 5. So 16.66 minus 22.22 is equal to minus 5.56, because smaller number minus bigger number. So minus 5.56 divided by 5. Further, if you simplify, you will get answer A is equal to minus 1.112 meter per second square. Meter per second square is a unit of acceleration. So now this negative symbol shows that, what it shows as negative symbol? It shows that a decreasing change in velocity. Okay, so negative sign indicates that the velocity is decreasing. So velocity is decreasing means that is acceleration is negative. We can say that acceleration is negative, or this is a deceleration or retardation. Is it clear, children? This is a very easy sum. So only thing is you have to convert kilometer per hour to meter per second. Is it clear? So now we'll go for one more sum. So now this is a formula to calculate acceleration. A is equal to V minus U by T. So this is second sum. Listen carefully. A train start from a railway station and moving with uniform acceleration, attain a speed 40 km per hour in 10 minutes. Find its acceleration. First, you have to understand the sum here, okay? So first you need to find out, so which one is initial velocity, which one is final velocity, okay? So only one velocity they have given, 40 kilometer per hour. What is that, whether that is initial or final? See what they have given: a train starting from railway station. A train starting from railway station means, obviously in railway station, train is at rest, okay? One thing you should remember: any object starting from rest means you can take it initial velocity as 0. Keep in your mind, okay? So now initial velocity will become 0. Initial velocity u is equal to 0, and time taken they have given 10 minutes, okay? Next, final velocity. Why 40 kilometer per hour is a final velocity means, after 10 minutes it attaining means it acquires 40 kilometer per hour velocity. So it is a final velocity. So final velocity is 40 kilometer per hour. Initial velocity is 0 meter per second, because train is starting from rest. So here speed is in kilometer per hour and time is in minutes. Obviously we have to convert both. We have to convert into second. Time we have to convert into second, and velocity we have to convert into meter per second. So this is how we have to convert. So 40 kilometer per hour to meter per second is divide multiplied by 5 by 18, and here 10 minutes you want to convert into second. 1 minute is equal to how many second? 60 second. So 10 into 60 is 600 second. That conversion is over. Time is in second. So next, here further if you simplify, 40 into 5 is 200, so 200 divided by 18. So further if you simplify with 2 table, 2 nines are and 2 hundreds are 200. So final velocity is 100 divided by 9 meter per second. Okay, we'll keep as it is. Anyhow we have to substitute in the formula, no? So we'll keep it as it is. V is equal to 100 divided by 9 meter per second. So next we'll substitute all the values. You know the formula: A is equal to V minus U by T. So A is equal to, V value is 100 divided by 9 minus U value is 0 because initial velocity is 0, and divided by 600. T value is 600. So now further if you simplify, 100 divided by 9 minus 0 is 100 divided by 9 only, and divide by 600. If we take it reciprocal, because division will become multiplication, so 1 divided by 600. So further if you simplify, 100 divided by 9 into 600, okay? So now if you simplify further here, you will get 1 divided by 54 meter per second square. So that's a unit, meter per second square. Or if you want to convert this into decimal, 0.018 meter per second square. Is it clear? Okay, so A is equal to 100 divided by 9 into 600. 20 get cancelled, so numerator is 1 only, denominator 9 6 are 54. So that is a 1 divided by 54 meter per second square. You can write it as it is, or if you want you can convert into decimal, that is 0.018 meter per second square. So this is the acceleration of the train. Is it clear, children? So we'll go to next sum. Okay, fine. So next one, third one. This is third sum. This is regarding equation of motion. Listen here. A bus starting from rest moves with uniform acceleration 0.1 meter per second square for 2 minutes. Here they have given acceleration itself. Okay, so acceleration is 0.1 meter per second square. Find, so first one we have to find out the speed acquired. So speed acquired is nothing but final velocity only. Okay, speed acquired. Next, the distance traveled. So we should find out distance traveled. What is the symbol of distance traveled? Yes. So we should find out S value also. Okay. A bus starting from rest. I told you, starting from rest means initial velocity will become 0. Okay, first we'll write given. So what they have given? A bus starting from rest means u is equal to 0 meter per second. Start from rest. Next, final velocity we have to find out. Speed acquired. Acceleration they have given 0.1 meter per second square. And time they have given 2 minutes. We have to convert into second because acceleration is in meter per second square. Is it clear? So 2 minutes we need to convert into seconds. So 2 into 60, that is equal to 120. So this is how what they have given, and we should find out even s also. S value also we need to find out. Okay. First one, speed acquired. Speed acquired is nothing but final velocity. So we need to find out final velocity here. So what is the formula to find out final velocity? You recall all three equation of motion. So we have to select the three equation of motion according to the given data. So first we need to write the given data. Then we need to select the equation of motion. So what is the first equation of motion? V is equal to u plus at. Yes, this equation of motion we can use because u is that u already we found 0, and a also acceleration they have given, time also they have given. So we can find out final velocity by using first equation of motion. So substitute all the values. V is equal to 0 plus 0.1 into 120. So 120 second is a time. So further if you simplify 0.1 into 120, if you multiply here 10 you can remove here. So 0.1 become 1. So 1 into 12. So 1 into 12 is 12 meter per second. So 12 meter per second is a final velocity. Is it clear? Next is distance traveled. So we need to find out distance traveled here. S value we need to find out. And we have to use second equation of motion. S is equal to ut plus half at square. So S is equal to ut plus half at square. Here t square I have given. Okay, listen. So u value is 0 and t value is 120 plus half 1 by 2 into acceleration is 0.1 into t. T square is that. So t square means 120 whole square. I didn't mention 120 whole square here. So 120 whole square we can write 120 into 120. 2 times we can write, no. So now further if you simplify, 0 into 120 is 0 only. Now here 1 into 6 I have written. So how 1 into 6 means? The same here before in final velocity 0.1 into 120. So 0.1 into 120 is how much? That is 12 only, no. So directly I have removed here. So 0.1 into 12, or else you can remove like 2 ones 2 6 60, right? So 120 becomes 60. 60 into 0.1 becomes 6. Is it clear? So 1 into 6 into the last one 120 I have written as it is. Next, for the simplification, if you multiply 1 into 6 is 6. So 6 into 120 is 720. So 720 meter is a distance traveled by the bus. Is it clear? Okay, fine. So we'll go for one more sum. So this is the next one. So this is also by using equation of motion only. Only thing is we have to select the equation of motion by writing given data. Okay. A train is traveling at a speed of 90 km per hour. So already train is in motion. So a train is traveling at a speed of 90 km per hour. Next, brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. See the concept here. Brakes are applied. So brakes are applied means obviously object should come to rest, or train should come to rest. So acceleration will become negative. Why? Because velocity decreases. Is it right? So brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find out how far the train will go before it brought to rest. means before coming to the rest, how far it travels. Means we need to find out distance traveled by the train before coming to rest. Is it clear? So once again you listen. A train is traveling at a speed of 90 km per hour. A train is already in the motion. Brakes are applied. Brakes are applied means it comes to rest with the acceleration of minus 0.5 meter per second square. Sometimes they won't give minus sign, so you have to consider as a minus sign. Okay, you should consider, because brakes are applied means obviously object should come to rest. That should be negative acceleration. Is it clear? So we need to find out distance traveled by the train before coming to rest. So first we'll write given. So what they have given, a train traveling at a speed. So already train is in motion, so that it is a final initial velocity. Okay, initially it has 90 kilometer per hour velocity only. This is not final velocity, it is initial velocity. Finally it come to rest. Is it right? Brakes are applied, obviously. Finally train comes to rest. So finally train comes to rest means final velocity will become 0 here. And conversions we have to do. Why? Because acceleration is in meter per second and velocity is in kilometer per hour. No, so we have to convert kilometer per hour to meter per second. Same as it is kilometer per hour, 90 kilometer per hour, we are going to convert into meter per second. So 90 into 5 by 18. This you should remember. Okay. So 5 by 18, 18 ones are 18 fives are 90. So 5 into 5 is 25 meter per second. So initial velocity is 25 meter per second. What about acceleration? Acceleration they have given minus 0 meter per second square, and final velocity will become 0 because train is coming to rest, motion to rest. Any object finally it come to rest means final velocity will become 0. Keep in your mind. If in case any object starting from rest means initial velocity will become 0. Don't forget this one. Okay. So next further, distance travel, we need to find out distance travel. So we know equation of motion, second equation of motion is meant for distance only, right? S is equal to ut plus half at square. You see first whether they have given everything or not. So here time they have given, they didn't give time at all. If time they have given means we can use second equation of motion. What is second equation of motion? S is equal to ut plus half at square. But here they didn't give time, so they didn't give time means we can't go second equation of motion at all. So what about third equation of motion? First equation of motion is we don't have distance at all. Third equation of motion, we'll see third equation of motion. So we have to go through third equation of motion because we don't want time to calculate distance in third equation of motion. Okay, that is 2as is equal to v square minus u square. Is it clear? So now we need to substitute all the values. 2as means 2 into a into s. Okay, is equal to v square minus u square. See now I'm going to substitute all the values. 2 into a value is minus 5 into we have to find out s. Write down s as it is equal to, oh, that is 0 square, because final velocity is 0. No, that's like 0 2, that should be 0 square. Okay, you can correct it. 0 square minus 25 square. So for 25 square I have put here 0, I didn't put. So now 0 square, that is not 0 to 0 square. Okay, so next step, anyhow 0 square is 0 only, and here you see simplification. 2 into 0 0.5 is 1. 0.5 if you write 1 by 2, 2 get cancelled, so 1 minus sign is there, so minus 1. So minus 1 into s is equal to, here I have written 25 square, I have written minus, because minus sign as it is, minus 25 into 25. So both left hand side minus right hand side minus we can cancel. So s is equal to 25 into 25, 625. Is it clear? So therefore the train travels 625 meter before got to Rest means before coming to rest, train travels 625 meter. Is it clear, children? It is very easy sum. Only thing is you have to collect the data. So by collecting the data, you need to select the equation of motion. See here, they are asking you to find out distance travel. We can go for second equation of motion itself. No, but here they didn't give time taken, right? So time they didn't give, so that we go for third equation of motion, that is 2as is equal to b square minus u square. This is how you have to select the equation of motion. Next we'll go for one more sum. There's a third one. Listen carefully. A trolley, while going down an acceleration of 2 meter per second square. A trolley is coming down. It's a inclined. It is a inclined uh, surface. It is coming down. Its acceleration is 2 meter per second square. What will be its velocity? What will be its velocity 3 seconds after the start? So after starting 3 seconds, what will be its velocity? Now tell me whether this is initial velocity or final velocity. So we have to find out initial or final velocity here. See, clearly they are given here. What will be its velocity 3 seconds after the start? So after 3 seconds, what is the velocity of the trolley? So we have to find out final velocity. What about initial velocity? Initial velocity will become 0. Why? Because after start, after the start means obviously the trolley should start from rest only. Is it clear? So initial velocity will become 0 here. So I have written given. So given acceleration, they have given 2 meter per second square, and initial velocity will become 0 because trolley start from rest. And final velocity we have to find out. Next, time taken also they have given 3 seconds. Next, we know formula. First equation of motion only we can use because everything is there. So v is equal to u plus at. So v is final velocity. No, substitute all the values here. Simplify it. You will get answer 6 meter per second. So 6 meter per second is a final velocity. Therefore, the trolley acquires 6 meter per second velocity after 3 seconds. Is it clear? This is very easy, very simple sum. Okay. Only thing is you have to collect the data properly. And the last sum. This is one more sum. A racing car has a uniform acceleration of 4 meter per second square. This is an acceleration. What distance will it cover in 10 seconds after start? Again after start. After start means obviously before starting the car is at rest. So initial velocity is 0. Is it clear? After 10 seconds, what distance it covers? So we have to find out S value. Is it clear? So first we'll write given a is equal to 4 meter per second square and t is equal to 10 second time they have given here, and initial velocity is 0 only because after 10 second after start. 10 second after start means before it was at rest. So initial velocity is 0. Then S value we need to find out. Next, the same formula, second formula itself we can use for finding S value because time is there, right? Time is there, initial velocity is there, acceleration is there. This is enough to find distance by using second equation of motion. S is equal to ut plus half at square. You can substitute all the values. 0 into it because initial velocity is 0. 0 into 10 plus 1 by 2 into 4 into 10 square. So 10 square we can write 10 into 10, and 0 into 10 is 0 only. So 2 into, how 2 means 2, we can cancel 1 by 2, right? So 2 ones are 2 twos are, and 10 we can write, 10 square we can write 10 into 10. So 2 into 10 into 10 is 200. So distance travel, therefore distance travel by a racing car is 200 meter. Is it clear? So 200 meter is a distance travel by the racing car after 10 second. Is it clear? So these are very easy sums. Only thing is you have to collect the data properly. Okay. So now we came to end of the session. Topic discussed. Means today we have discussed these topics: three equation of motion and problems on acceleration and equation of motion. So three equation of motions are: first equation of motion, v is equal to u plus at. Second equation of motion, s is equal to ut plus half at square. Third equation of motion, 2as is equal to v square minus u square. So these three equation of motion you have to remember. Is it clear? Okay. And next class we'll discuss few more sums regarding this equation of motion only. Okay, thank you children. Have a nice day.